graph shows y equals x cubed and the graphs that result from the transformations in problem 1. In general, y equals a times the difference x minus h cubed plus k represents all of the cubic functions you can obtain by stretching, compressing, reflecting, or translating the cubic parent function y equals x cubed. First note the parent function is graphed here in gray, and its compression by a factor of 1/2, the equation y equals 1/2 x cubed, shown in orange. Next, we can reflect the orange or red curve across the x-axis by multiplying our leading coefficient by -1. So y equals -1/2 x cubed. Next, the blue curve is translated to the right and upward. So translated 3 units to the right with the x minus 3 in parentheses, and up 2 units with a +2 outside of the parentheses. Problem 2. Finding zeros of a transformed cubic function. And this one's multiple choice. If a, h, and k are real numbers, and a does not equal 0, how many distinct real zeros does y equals -a times the difference x minus h cubed plus k have? Is it a, 0, b, 1, c, 2, or d, 3? We'll consider the related equation, the negative of a times the difference x minus h cubed plus k equals 0. X is a 0 means it's an x-intercept, so y equals 0. And now we can work to solve for x. We subtract k from each side, divide each side by -a, apply the cube root to each side of the equation, and finally add h. So in the end we see that x equals the cube root of k over a plus h. Keeping in mind that a, h, and k are all real numbers, this tells us that x equals one distinct real number. So disregarding multiplicities, the function has a single real zero, and the correct answer is B. Your turn. What are all the real zeros of the function y equals 3 times the difference x minus 1 cubed plus 6?